Hey, hello, and welcome to the show. It's me, JP, and it's time for JP's product pick of the week. Right here in my sort of post-apocalyptic workshop, I had to move a ton of stuff from over there. You can see right there. Patching a hole in the back of the garage. This was a garage before I turned it into my workshop, and the previous owner had knocked out, 5 or 6 of the studs that hold up the wall to make a hole, to make a box to fit like his bumper on his car. He had a huge Buick or something like that. So it's been like that for 20 years or more now, and I'm finally fixing it. So pardon the mess, the messier than usual mess here. Let's see. So, also, full disclosure, because we're doing those things with machine learning. I refuse to call it artificial intelligence, but with machine learning, a friend of mine made that image using one of the machine learning tools and gave it a description, and then I superimposed part of my face. Most of it, including the beard and the hair, were from the AI and looked weirdly like me. And the workshop looks weirdly like mine. That's from a description. I feel like it's been training on my videos or something, because, hey, weird. And since I'm talking about the process here, half of that background wasn't there, and I added it with Photoshop's generative fill. So to the right, screen right, or character right, screen left, none of that was there. And in Photoshop, I said extend the background, and it just nailed it, which is wild. So that's that. All right, let's get on with this show. Woo! Hey, what's happening? Okay, so first of all, if you want to go and check out the product pick and get a jump start on it, you can head to that URL or to that QR code. It is product ID 3190, so you can jump on over there. You can watch the show from inside there. We broadcast the show inside of the page, and you will see that it is on discount. You can get it for half price during the show. After the show, it'll go back to full price, but if you want to get this week's product pick, throw some in your cart and maybe some other things, and just hit go before the end of the show, and you'll get it for half price. But before I say any more, let's have Lady Ada jump back a little bit in time to tell you about this week's product. Take it away, Lady Ada.
We have a little motor driver. So it's a cute little motor driver, but despite it being cute, it's quite powerful. So some people wanted some high power motor control. These can do up to 3.6 amps, up to 45 volts. They're very basic. It just uses 2 PWM or digital inputs to control the motor, but really good when you have just a large motor. It also has built-in current limiting, which I kind of like. So you can limit the current using an external resistor. It's not a sense resistor, so it's not in line with your signal, so it like doesn't get hot. You don't have to worry about having like a 0.001 ohm resistor. Instead, it I guess it's used as like a current multiplier or like a internal circuit that is current limiting. So there's an external resistor, about 30K is what we put on there to start, but you can adjust it as necessary to change the current. So we thought, set the current limit to about 2 amps. That's a pretty good place for most motors. So when you put it on your Rover, if you stall out, you won't like tear through your battery. It'll just like stop working instead of just like fighting, the motor like continuing to fight the whatever is obstructing it. And I've got a simple demo here. So this is just got Arduino compatible, and then I have it hooked up to the 2 PWM outputs. So this is 9 and 10, and then I just slowly ramp up and down. It only drives one DC motor, but if you want to have that much current going through a motor anyways, you'll want to have a separate chip. So let me turn this on. Give it a second to start up. There you go. Okay, I don't know why it was. So it speeds up the motor one direction, slowly speeds up, speeds back down, and then goes the other direction. So it's just a very simple demo of, sorry, it's so loud. It's a very simple demo of a motor. And then, if you're running the motor and you hold this so it can't turn, it does fight, but it, eventually just like, it doesn't keep going after a certain current limit. So it's good for your batteries if you have a power supply that's limited.
See, when I fight, I just keep going.
Yeah. Does that. It also has internal thermal protection, under voltage, a couple other things. That's a cute little motor driver, handy for robots and stuff.
Okay.
That's it.
Handy for robots and stuff. Sign me up. Yeah, look at that. That right there. That is the gorgeous little product pick this week. Right there, that is my product pick this week. It is the DRV8871 DC motor driver breakout. So this has everything you need on it. It can take anywhere from 3.6, is that right? No. I'm getting my numbers mixed up. Yeah, it can take anywhere from 6.5 volts up to 45 volts DC through the terminal jack that you can solder on one of these. And then it'll output to your DC motor, and you can control it just with 2 pins, or even just one if you're only going in one direction, of PWM control coming from your microcontroller. So let's see. Let's take a look at some things here. First of all, there's the page right there. So go and check that out. It's like I said, product ID 3190. So this can go up to 3.6 amps of current. By default, when it comes to you, it's set for 2 amps. So when it tries to draw more than 2 amps, it will shut down to save your batteries from getting chewed up. You can change out the resistance level of that little resistor you see on there. There's a little resistor on there that's a surface mount, but you can put on your own resistor to change the value of that current limiting. What else does it have? Thermal protection, so if it gets too hot, it'll stop. Under voltage protection, and you don't need to give it any logic level voltage separate. So you can just feed it the DC voltage that it's going to use for driving the motor, and it'll sip off of that what it needs to drive the chip. You can use a 3.3 volt logic level microcontroller or a 5 volt logic level microcontroller. Those will work. And we've got libraries in CircuitPython, or rather, I should say, you don't need libraries, right? You just need to be able to PWM. So anything that can PWM can tell this way to go. It is an H-bridge driver, which means you can send the current flowing, or the voltage flowing, in either direction. So you can run forward and you can run reverse on your brushed DC motor. So this page here will give you some of those specs, as well as there's a link in here to the Learn Guide. And so you can check this out right here. This will show you all of the basics of it, including the pinout. So you can see here on the pinout, there's the motor power pins. Those are broken out both as some little headers, so you can solder wires directly to that, or to pins to put into your PermaProto or your breadboard. So you can feed it the voltage that's going to be driving the motor there, or, and I prefer this, use the included terminal blocks and feed it from there. You've also got your input pins, so input 1 and input 2, and that'll just say if we PWM one of those up, we will drive in that direction. If we PWM the other one up, we'll drive in the opposite direction. And then there's that motor output pin. So what I thought I'd do is show you a little demo I put together of this in action. Let's jump to, how about that view right there, and let me zoom out a bit. So let me give you a little tour here, in fact. So there you can see is my DRV8871. It has PWM pins and ground coming from this Itsy Bitsy. It's a Itsy Bitsy RP2040. And then I have a DC jack plugged into a big battery pack. If I lift up my Lego contraption, you can see this is a large AA battery pack. You can feed that from a wall wart as well. Just for convenience, I'm using a battery pack. And then that is driving this motor that you see back here. And I've grafted onto that one of our little Technic pin, Lego compatible Technic pin axles for the drive shaft. And we can focus better than that. There we go. Let me move myself over to that side. There, you can see it a little better now. So there's the type of DC motor we're driving. There's my Itsy Bitsy. Here is the DRV8871. It's driving the motor under there, and we're getting DC power from battery. And then I have a little Technic gear train there. So if I give this microcontroller power, it will start sending PWM to tell the motor to go in one direction, slow it down, and then go in the other direction. So this could be any type of hobby application. In this case, I'm driving some Lego without having to use sort of official Lego motors and microcontrollers and Blockly programming languages. Instead, I just wanted to use CircuitPython. But you can, of course, use this for any type of small motor application up to a 45-volt motor that draws up to 3.6 amps. So it doesn't have to be tiny. So let's take a look at the code that I've got running on here. So in CircuitPython, I am simply, I'm just going to pull the power. Pull the power from the motor there so it's not yelling at me. So I've simply got PWM-IO imported into the microcontroller, and then I've picked two pins. Pin D7 and pin D9 are a good pair of PWM pins on the RP2040. So I'm setting up one as motor in 1 and the other as motor in 2. And then you can tune the frequency here to something that works well. I found this 2600 after experimentation seemed to work pretty nicely as a PWM frequency. And then I've set a max value, and that's at half duty cycle, only because I don't want to burn out the motor, and I've got 12 volts of battery going into this, so I don't want to send the full range. So I'm doing about half range on the PWM to tell the driver to drive at about half that available voltage. And then in my main loop, all I'm doing is setting my duty cycle on one pin to essentially be low as essentially the ground reference. And then the other pin, I'm just ramping up. You can see one unit at a time here. It just ramps up to the max, which is this 32,768. Then we wait 8 seconds. That's why it's going to run for a little while. And then I slow it down. So just run that same thing in reverse, wait a second, and then switch to the other side. So if I give this power again, it's been running this whole time. You can see it doing its thing there. I'll go back to a full view. You can see that doing its thing, and there's our little driver board telling that motor what to do. All right, so I'll pull that again. Let's see, what more is there to say? I think that covers it. If you want to get this for the discount price during the show, all you got to do is head to that URL right there, 3190, and take a look at the board right there. Now, this is a single motor. It can drive in 2 directions, but really it's a single motor it's going to drive. So if you want to, you can use multiple of these as long as you have PWM pins, and I think there's probably 10 sets of them or something like that on the Itsy Bitsy. You can drive a bunch of these, just give them adequate power. And then you can either set up a whole bunch of motors, or you can set your timing to drive things like stepper motors, 1 coil per. So there are probably better drivers for that sort of thing, but there's nothing to stop you from doing that. Let's see, questions. DJDevon3 asks over in our Discord, can this be used with 130 hobby motors? I don't know which ones those are. Maybe a link, I'm not sure. Yeah, these are the TT motors, which are geared already, and then I'm further gearing it down with the Lego there. But these, on their own, if you look at the back of the demo here, I have one of the, since this has a shafts running through both sides of the body there, you can see this one's spinning at full speed. So that's the full, or rather half, I guess, half speed. Full safe speed on this motor is that there. I think the specs are in the product pages for the different motors that we have. We also have the metal shaft versions of these and the bimetal. If you take a look at this one here, that's the one I'm using. So this one's a 3 to 6 volt, so lowest you can give it is 3. And you'll hear it'll whine a little bit as we're ramping up until it hits that 3 volts where it can start moving, and then further it'll go faster as it gets up to the 6 volts. So this is one of the many that we have. I think if you look up TT motor in our in the store, you'll see we've got different gear ratios, 1 in 90, 1 in 90, 1 in 90, This is a 200 RPM. We've switched units here, so I'm not sure which or which. But any of those motors there are a great choice. And you can also just drive these bog standard toy motors. Do we sell them on their own? Yeah, this guy, this little toy DC motor. Oh, so that's a 130 size, yeah? Yeah, you found it for me, thank you. Yeah, so that's a typical, I didn't know those were called 130s. Yeah, so that's a pretty typical one that I tore out of every toy when I was a kid and was trying to see how it worked. That's the motor you found. I've got a drawer full of them. In fact, I just ran across. So these guys with the little flat shaft, you'll also find round ones. You'll drive any of those. These, I think, ones I pulled out of VCRs or something like that. Okay, so let's see. I think that covers all the features on it. The Learn Guide, some of the motors that you can expect to drive with that. And let me know if there's any other questions. What a handsome little minifigure. Isn't that guy cute? In fact, I wanted to show you that in the full sort of twisted demo of this, my little minifigure there is doing who knows what to this weird mad scientist guy. Let's zoom down a little more. I don't recommend torturing your toys, so maybe this guy asked for it. Who knows? Is that weird? It's kind of weird. But look at that guy. Have you ever seen a minifigure with a double tall head? He's a weird guy. Is that actually his head or is it an add-on? Yeah, it's kind of his hat is another head. Oh my God, that guy's weird. Okay. Also, there's this cat right here. Okay. That's enough playtime, right? So, yeah, this doesn't look safe. I don't know what's happening here. It's all gone off the rails. That's going to do it, though. So head on over here, pick some up. You can get them for the half price during the show. Right there, they are $3.75. They are still in stock. You get maximum of 10 per customer, depending on what you want to do with them. You might want a whole slew of them. Note these also have mounting holes, so you can hook them up to your project a little more easily than I have with the Legos here. All right. That will do it. So thanks everyone for stopping by, and I will see you later in the week. Don't forget we have other shows coming up, such as 3D printing hangouts tomorrow morning, and then we have show and tell and ask an engineer in the evening, and I'll be back with a workshop show on Thursday, and I might have even cleaned up some of this stuff by then. So I will see you then. Thanks everyone for stopping by. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week.